Suppose f of x comma y equals 5x plus 3y, and the region R is a rectangular region shown below on the xy coordinate plane. We're asked to evaluate the given double integral. Let's begin by defining the region of integration in terms of x and y. Notice how the interval for x would be the closed interval from -1 to 3. The interval for y is also the closed interval from -1 to 3, which gives us this rectangular region of integration. In our previous examples, the given function was non-negative over the region of integration, and therefore the double integral was the volume of a solid. This is not the case in this example. This function is negative in portions of this region of integration. Let's take a look at this graphically. The graph of f of x comma y is graphed here in blue. We can view the region of integration by looking down on the xy plane, which we see here. And notice how this part of f of x comma y is non-negative over the region, but for this triangular region here, f of x is negative, which we can see when we rotate this. Notice how this plane does drop below the xy plane in this region here, and therefore in this case a double integral does not give us the volume of a solid. So going back to our example, notice how it does specify to integrate with respect to x first and then y. So this is going to be equal to the double integral of f of x comma y The interval for x, again, is from -1 to 3. The interval for y is also from -1 to 3. Let's evaluate this double integral on the next slide. We first integrate with respect to x, treating y as a constant. So we'd have 5 times x squared divided by 2, or 5 halves x squared. And then for 3y, we'd have plus 3 y times x, or 3xy. So be careful here, we're substituting these values for x, not y. So we'd have 5 halves times 3 squared plus 3 times y, and then minus 5 halves times -1 squared plus 3 times -1 times y. Now I need to simplify. So here we're going to have 5 halves times 9, that's 45 halves, plus 9y, minus the quantity here we'll have 5 halves, and then minus 3y. Simplifying again, we have 45 halves minus 5 halves, that's 40 halves or 20. Then we have 9y minus -3y, or 9y plus 3y, which is 12y. Now we integrate with respect to y. So we have 20y plus 12 times y squared divided by 2, that'd be 6y squared. First evaluate at 3, so we have 20 times 3 plus 6 times 3 squared minus, substitute -1 for y, so we have 20 times -1 plus 6 times -1 squared. So here we have 60 plus, this would be 54, so we have 114 minus -20 plus 6, that's -14. So we have 114 plus 14, which equals 128. This would be the value of the given double integral over the given region. I hope you found this helpful.